Something came back from the edge of everything. Not a greeting, not a confirmation, not the clean, predictable stream of data that NASA engineers had spent decades learning to read. What came back was something that broke protocol, triggered emergency systems, woke up hardware that had been completely dead since 1981, and forced some of the most brilliant minds on Earth to sit in silence, staring at screens, asking each other a question nobody wanted to say out loud. Voyager 1, humanity's most distant creation, drifting 15.5 billion miles beyond everything we have ever known, went dark. And when it finally spoke again, what it said wasn't supposed to be possible. There is a machine somewhere in the darkness between stars. It is not near Mars. It is not orbiting Jupiter. It has long since crossed every boundary that science once drew around our solar system, punching through the invisible wall at the edge of the sun's reach and entering territory that no human instrument had ever entered before. It travels at 38,000 miles per hour. It has been traveling for over 47 years, and it was built by engineers who used slide rules. Think about that for a moment. The people who designed Voyager 1 did not have personal computers. They did not have the internet. They did not have modern microchips or GPS or even the digital calculators that teenagers use for homework today. They built something by hand with 1970s technology, and that something is now the farthest object humanity has ever sent into the cosmos. More than 24.9 billion kilometers from the sun, gliding silently through interstellar space, still alive, still listening, still sending data home. And in October of 2024, it stopped. Not slowed, not degraded, stopped. The signal vanished. On October 18th, NASA's Deep Space Network, a global array of enormous radio antennas that acts as Earth's ear to the cosmos, detected nothing from Voyager 1. No signal, no carrier wave, no whisper of data. For a machine that had been speaking to Earth continuously since 1977, across distances so vast that light itself needs over 22 hours to cross them, the silence was not just unusual, it was alarming. The mission team, based at NASA's Jet Propulsion Laboratory in Pasadena, California, immediately began running through every scenario. Hardware failure, power crisis, a fatal malfunction 15 billion miles away that no human hand could ever reach to fix. The questions piled up fast, and the answers did not come. But here's where it gets deeper than most people realize. This wasn't the first time Voyager 1 had fallen into mystery. Just 1 year earlier, in November of 2023, the spacecraft began transmitting complete nonsense. Not silence, something worse. Data was arriving from Voyager 1, but it was gibberish, meaningless strings of ones and zeros that corresponded to nothing in any known format. Engineers spent 5 agonizing months trying to diagnose the problem from across the solar system, sending commands that took 22 hours to arrive, and then waiting another 22 hours for the response. Eventually, they discovered the culprit, a single corrupted chip. In Voyager's flight data system, the onboard computer responsible for packaging and transmitting scientific data. One chip, on a spacecraft 24 billion kilometers away, built in the 1970s. And they fixed it, not by sending a repair crew, not by replacing hardware. They fixed it by essentially rewriting portions of the spacecraft's software and redistributing code around the damaged memory, like rerouting traffic around a broken bridge, a bridge that existed more than 14 billion miles from the nearest mechanic. That alone should be considered one of the most extraordinary engineering feats in human history, but the world barely noticed. And that is the first thing that mainstream coverage has consistently failed to capture, the sheer, breathtaking improbability of what NASA's Voyager team does every single day. These are people managing a spacecraft launched before most of them were born, using technology older than their parents' marriages, communicating across distances that make the word remote sound almost quaint. And then, just months after that crisis was resolved, October arrived. What most people are not seeing in the coverage of this latest blackout is the sequence of events that preceded it. On October 16th, 2024, the mission team sent a routine command to Voyager 1. They wanted to activate one of the spacecraft's heaters. A simple command, the kind of housekeeping task that teams perform regularly to keep aging hardware functional in the extreme cold of deep space, where temperatures plunge to approximately minus 270 degrees Celsius, just barely above absolute zero. It should have been uneventful. Instead, something the spacecraft had never done before happened. The command triggered Voyager 1's fault protection system. Understand what that means. Voyager 1 has an autonomous protective response built into its ancient computer systems, a set of reflexes designed to keep the spacecraft alive if something goes wrong. If the probe detects that it is drawing more power than its radioisotope thermoelectric generators can safely supply, the fault protection system kicks in automatically and starts shutting down non-essential systems. No human decision required, no consultation with Earth. The spacecraft just begins making survival. It switched off Voyager 1's X-band transmitter, the high-powered radio the spacecraft had been using to communicate with Earth for decades, and it switched on something else, something that had not been used since 1981. A backup S-band transmitter operating at a far lower frequency, transmitting a signal so faint that engineers at JPL weren't even certain their equipment could detect it from Earth, given how much farther away Voyager now is compared to the last time this transmitter was active. When the S-band was last used, Voyager 1 was a fraction of its current distance from Earth. The spacecraft has been moving away from us every single second since then. Now, more than 40 years later, this whisper of a signal had to cross 24.9 billion kilometers to reach home. On October 19th, the signal stopped entirely. Even the faint S-band went quiet. For 6 days, Voyager 1 was completely silent. Think about what that means in practical terms. The engineers at JPL did not know if Voyager 1 was still functioning. They did not know if the spacecraft had experienced a catastrophic power failure. They did not know if they had, after 47 years of flawless interstellar flight, finally lost it. Every command they could send would take 22 hours to arrive. Every response, if there was one, would take another 22 hours to return. A single diagnostic exchange took nearly 2 Earth days, and they were diagnosing a machine built with technology from the Nixon administration, running on less electricity than a refrigerator light bulb somewhere in the dark between stars. On October 22nd, the team made a calculated decision. They sent a signal, not to Voyager's X-band, which had triggered the fault protection system, and which they feared might cause further damage if reactivated, but to the S-band. They were essentially shouting into the dark with the hope that a 43-year-old backup radio, dormant since Ronald Reagan was still a few months away from winning his first presidential election, would hear them and respond. Then they waited. 22 hours for the signal to arrive. 22 hours for any response to return. 44 hours of silence. On October 24th, 2024, Voyager 1 answered, "Back." And the mission team at JPL, those extraordinarily patient and precise engineers who had been living this anxiety for days, could finally breathe. But they were careful not to celebrate too loudly because the work was far from over. The S-band signal, while technically functional, was too weak to serve as a long-term communication channel. The X-band had to be restored, and to restore it, they first had to understand exactly what had gone wrong, without the luxury of being able to physically inspect anything. What informed sources within the mission have made clear is that the power situation aboard Voyager 1 is now reaching a genuinely critical threshold. This is not a new problem, but it is an accelerating one. Voyager 1 is powered by radioisotope thermoelectric generators, essentially nuclear batteries that convert heat from the natural decay of plutonium-238 into electricity. These batteries are not eternal. They lose roughly 4 watts of electrical power per year. When Voyager launched in 1977, its generators were producing approximately 470 watts. Today, after nearly 5 decades of decay, the spacecraft operates on somewhere between 250 and 270 watts, less than 3 standard light bulbs. The spacecraft has to power everything with that. Its computers, its science instruments, its heaters, its antenna, its fault protection systems, everything. This is why the mission team has been systematically shutting down instruments for years. Voyager 1 launched with 10 scientific instruments. One by one, as the power budget shrank, instruments were switched off. The cosmic ray subsystem experiment was deactivated in February of 2025. The low-energy charged particles experiment, known as LECP, was powered down in April of 2026, having already been switched off on its twin Voyager 2 the previous year. Each shutdown is a small kind of death. A sensor that once told humanity something unique about the universe going permanently dark because the spacecraft simply cannot afford to power it anymore. And here is where everything changes. Because while the world was focused on the communication blackout drama of October 2024, something far more scientifically significant was quietly unfolding in the background. Before the blackout, and stretching back years, Voyager 1's instruments had been returning data that didn't quite fit existing models. In 2020, the spacecraft's magnetometer registered an abrupt jump in the intensity of magnetic fields embedded in the interstellar plasma surrounding the probe. Simultaneously, the plasma density detector measured a corresponding rise in plasma density. Scientists initially categorized these as transient events, pressure pulses traveling outward from the sun, slamming into the boundary of the heliosphere and sending reverberating waves through interstellar space. This was a known phenomenon, explainable, manageable. But here's what wasn't manageable. The anomalies that began in 2020 did not stop. They did not return to baseline. They persisted, growing in intensity, continuing in ways that the standard models simply could not account for. Some mission scientists began to quietly question whether these anomalies were being driven by solar activity at all. The real story is that Voyager 1 is not just telling us about space. It is telling us that our understanding of the boundary between the solar system and interstellar space, the heliopause, that vast transitional zone where the sun's influence gives way to the full force of the galaxy, is significantly more complex, more dynamic, and more structurally strange than any theoretical model predicted. The spacecraft is detecting environments that the equations didn't prepare us for, and every time engineers have had to power down an instrument to save electricity, humanity has lost another eye in that unexplored darkness, at precisely the moment when those eyes are reporting things we most need to understand. According to information compiled from multiple mission updates and scientific analyses, what Voyager 1 and has been observing in the very local interstellar medium, the cosmic neighborhood just beyond the solar system's edge, includes sustained magnetic field intensities and cosmic ray particle distributions that challenge existing theories of how our solar system interacts with the broader galaxy. Researchers working with Voyager data published findings in late 2025 indicating that low-energy cosmic ray measurements from beyond the heliopause reveal signatures of the local interstellar gas distribution that require entirely new three-dimensional models to explain. This isn't a minor calibration issue. This is a fundamental gap between what the universe was supposed to look like at 15 billion miles and what Voyager is actually seeing there. But there's another crisis that almost ended everything before any of this data could be recorded, and it happened in 2025, and most people never heard about it at all. Voyager 1 uses sets of thrusters to maintain its orientation in space. This is not optional. The spacecraft must keep its high-gain antenna pointed precisely at Earth to communicate. If the antenna drifts even slightly off target, the signal quality degrades. If it drifts significantly, contact breaks entirely. The roll thrusters, a specific subset of the primary thruster system, are what keep the spacecraft from slowly rotating away from its communication lock with Earth. And in early 2025, those thrusters were considered dead. They had been abandoned in 2004 after residue buildup from 2 decades of firings had clogged the system to the point where engineers deemed them unusable. The spacecraft had been operating on backup thrusters ever since, but the backup thrusters were showing signs of deterioration. The mission team was watching a slow-motion crisis develop, a spacecraft that, if it lost attitude control, would silently spin away from Earth, its antenna drifting off target, its voice fading, and then gone. The engineers did something remarkable. They went back to the records, the original engineering documentation from the 1970s, the technical logs from a mission that began before the internet existed. They studied whether the primary roll thrusters, the ones considered irreparably clogged for 2 decades, could somehow be brought back online. And they decided to try. They sent a command to reactivate the heaters on the dead thrusters, carefully, precisely, monitoring every response with the agonizing patience that a 44-hour round-trip communication delay demands. On March 20th, 2025, the test was successful. Thrusters that had been declared functionally dead in 2004 fired again. Deep space engineering at its most extraordinary. The Voyager team had, in the words of one scientist familiar with the mission, seemingly performed another miracle. There is something profound and slightly unsettling in all of this when you step back and look at the full picture. Voyager 1 is dying, not dramatically, not suddenly, but gradually, instrument by instrument, watt by watt. The spacecraft's ability to sense and report on the universe around it is diminishing. NASA estimates that communication with Voyager 1 can probably be maintained into the early 2030s, though the loss of science instruments will continue well before that final silence. The mission team is now exploring an ambitious plan, internally referred to as Big Bang, to attempt to restore power to the low-energy charged particles experiment on Voyager 1 after testing the maneuver on Voyager 2 first. If successful, it could buy the spacecraft's remaining science capabilities additional months or even years. If it fails, it could potentially accelerate the end. Now, what most people are not seeing is what the end of Voyager 1 actually represents. This is not simply the conclusion of a spacecraft mission. It is the closure of a window, a unique, irreplaceable, physically impossible to replicate window into a part of the universe that no other human instrument currently occupies. There is no replacement for Voyager 1. There is no Voyager 3. No subsequent mission has been launched to follow in its trajectory, to continue its measurements, to pick up where its dying instruments will leave off. When Voyager 1 goes silent, humanity will be blind beyond the heliopause. We will have one set of readings, one pass through that boundary, one data set from one moment in time, and then nothing. The universe beyond our solar system will go dark to us in a way that will not be reversed for generations, if ever. The implications of what has been coming back in Voyager's data are not trivial. The cosmic ray measurements taken beyond the heliopause, the first direct in situ observations of the local interstellar spectrum at low energies that science has ever obtained, are reshaping theoretical models of how cosmic rays propagate through the galaxy. These particles, accelerated to near light speed by supernova explosions and pulsar winds tens or hundreds of light years away, interact with the local interstellar medium in ways that were previously impossible to measure directly. Voyager 1's data suggests that the nearest significant sources of these low-energy cosmic rays may be located more than 150 to 200 parsecs from our solar system, a finding that, if confirmed, revises estimates of our local cosmic neighborhood and has implications for how scientists model the broader galactic environment. This is not abstract physics. This feeds into our understanding of how the galaxy is structured, how stars live and die, and how life-permitting environments form across the cosmos. And through all of this, through the corrupted chip and the gibberish transmissions and the 5 months of diagnostic silence and the October blackout and the 43-year-old backup transmitter whispering across 24.9 billion kilometers and the thruster resurrection and the instrument shutdowns and the power crisis, through all of it, a team of engineers and scientists at a laboratory in California has held on. They have adapted. They have improvised solutions that should not, by any reasonable engineering standard, have been possible. They have maintained contact with an object more than 15 billion miles away using technology designed when people were still watching television on cathode ray tubes. They have read the universe's most distant postcards and tried to make sense of what the universe is trying to tell us. But here's what keeps certain scientists awake at night. Not the failures, but what comes before the final failure. The sustained magnetic anomalies that didn't return to baseline, the plasma density readings that exceeded model predictions. The cosmic ray distributions that suggest our solar neighborhood is surrounded by something, a structure, a pattern, a boundary, characteristic that theoretical physics did not anticipate. Voyager 1 is not just experiencing technical problems. It is returning scientific observations that do not cleanly fit the existing picture of what interstellar space should look like, and the clock is running out on its ability to refine those observations. According to the engineering realities now unfolding, the spacecraft faces an increasingly narrow operational window. Each science instrument shutdown reduces the resolution of that window further. The LECP shutdown in April of 2026 removed one of the key sensors for measuring the energetic particle environment beyond the heliopause, precisely the environment that had been generating anomalous readings since 2020. That data stream is gone. The cosmic ray subsystem, shut down in February of 2025, had been one of the instruments detecting those unexpected radiation signatures. Gone. The instruments that remain are precious and numbered. When they go, so goes the last direct sense data from the only place in the observable universe where humanity currently has eyes. There's a philosophical weight to all of this that the technical reporting tends to skip past. When Voyager 1 launched in 1977, it carried with it a golden record, a gold-plated copper disc encoded with sounds and images of Earth. Music, languages, natural sounds, greetings from human beings in dozens of tongues, photographs of our world and our species. It was a message, a declaration of existence aimed at any intelligence that might one day intercept the probe in the vast dark of interstellar space. We sent a message out, and now, nearly 5 decades later, Voyager 1 is sending messages back to us. Messages written not in human language, but in magnetic field intensities and plasma densities and cosmic ray counts that don't behave the way the textbooks said they should. The universe, it turns out, has something to say back, and we are losing our ability to hear it. By the early 2030s, if current projections hold, Voyager 1 will fall permanently silent. The radioisotope generators will decay past the threshold needed to power even the most basic systems. The signal will fade, then vanish. And somewhere in the dark between stars, a small gold-plated disk will keep drifting, carrying the sounds of Earth through a universe that we now know is stranger than we ever imagined, past boundaries that don't behave as predicted, through magnetic fields that shouldn't be doing what they're doing, toward a destination that is nowhere and everywhere and unreachably far. The question that no one in the official briefings will ask directly is this: what is generating those sustained anomalies? What is creating magnetic field intensities and plasma densities that didn't return to baseline and don't match any model? What is Voyager 1 moving through out there in that territory between stars, where no human instrument has ever gone, and none may go again for a century? The engineers at JPL will give you the responsible answer, that these are complex physical phenomena requiring further study, that interstellar space is poorly understood precisely because we've never directly sampled it before, that extraordinary claims require extraordinary evidence, and that caution is the appropriate scientific posture. All of that is true, and all of that is correct. But the data keeps coming, and the data keeps being strange, and the instruments keep shutting down one by one, and the team keeps performing miracles that shouldn't be possible. And somewhere, at a distance that the human mind genuinely cannot comprehend, not the conceptual distance that you can nod at in a YouTube video, but the real, physical, Light takes 22 hours distance. A machine made of 1970s hardware and human ambition is still moving, still measuring, still whispering home through a backup radio transmitter that nobody expected to ever need again. The transmitter that went silent in 1981 spoke again in 2024. Voyager 1 came back from the dark once. It came back from the gibberish once. It came back from the dead thrusters once. It came back from the blackout once. The question that nobody has a clean answer to is how many more times it can come back. And the question underneath that question, the one that the sustained anomalies keep asking without resolution, is what exactly is out there, past everything we mapped and modeled and prepared for, in the dark place where Voyager 1 now travels alone? We built something extraordinary, pointed it at forever, and watched it go. And now it's sending back data that suggests forever is more complicated than we thought. The mission is ending. The instruments are going dark. The power is fading. And the universe beyond our solar system, that vast, uncharted, anomalous, magnetically strange territory that only one human object has ever entered, is going to go quiet for us soon, maybe for decades, maybe longer. Whatever Voyager 1 has been seeing out there, we are running out of time to understand it. And the window is closing faster than anyone wants to admit.